Welcome back to the channel. This is the Earth Science Classroom. This video is on astronomy. We're looking at the Earth, Moon and Sun system, and in particular looking at the Moon and the Moon's orbit around the Earth and the differences in the positions of the Moon as it revolves around our planet. This is the Earth Science Classroom. Our moon is the Earth's natural satellite, which means that this rocky body is revolving around our planet at a certain distance, at a certain velocity, and at a certain time or period it takes to revolve or make one complete revolution around our planet. And from this we can study the motion of the moon and calculate its ecliptic, eclipses, and different motions. Here we have a diagram showing the Earth and the Moon's orbital path around our planet. Now, for one complete revolution or one orbit around our planet, the Moon takes 27.3 days. Now, in addition to that, the Moon is tidally locked, which means that its spin is the same speed as Earth's spin. So we see one side predominantly, and the Earth has a axial tilt of 23.5 degrees, and also it's spinning on its axis around, in addition to revolving around the sun on the Earth's ecliptic. So back in 1609, Johannes Kepler, who worked with Tycho Brahe in Copenhagen, which is in Denmark, and an observatory, was studying Mars and used all of Brahe's information and detailed notes on planetary motion and fixed stars. He calculated that the orbits of both the planets and the moons were not perfectly circular. Now, this was the understanding of previous astronomers, that everything was circular and perfect. Kepler came along with his calculations in math and figured out that these orbital paths are not perfectly circular, but they are elliptical. Now, an ellipse is a squashed circle with two foci, and the moon orbits in an ellipse. Now, the measure of an ellipse using a math formula is called eccentricity. Now, that is a scale that goes from 0 to 1. 0 is a perfect circle, and 1 is extremely elliptical or oval. Our moon has an eccentricity of 0.05. So from the naked eye, it may look like a circle. However, mathematically, it is an ellipse. It is just not quite circular. It's a little bit squashed. Now, in comparison, the Earth's eccentricity is 0.017. So compared to the Earth, the moon has a more elliptical orbit. Now, because of Kepler's law and there being an elliptical orbit, there is a point in the orbit of the moon where the moon is closer to the Earth versus a point where the moon is further away from the Earth. Now, these two terms are called perigee and apogee. Perigee is where the moon is closest to the Earth, and apogee is where the moon is furthest away from the Earth along its orbital path. Now, the average distance of the moon from the Earth is the calculation of both the apogee and perigee over the course of the revolution, or 1 year, which is 239,000 miles. Now, that is the average between the apogee, which is 252,000 miles, and the perigee, which is 225,500 miles. So the difference between the apogee and perigee along the orbital path is 26,500 miles. And a consequence of this difference between the apogee and perigee would be the tides, the effect of the moon's gravity and the moon's orbit around the Earth on the world's oceans, and the tidal nodes and the height of the tides, be it semi-diurnal or diurnal or mixed tides around the world at different coastlines, different locations. But the apogee and perigee and the position of the moon would have an effect on the tides and how high or low the tides are based on the proximity of the moon and the effect of the moon's gravity. For example, during perigee, where the moon is closest, the effect of gravity from the moon on the Earth's body water and atmosphere and even the continents would be greater than at the point of apogee, where the moon is furthest away. Even though it's a small difference, there will be a difference in the gravitational pull of the moon on the Earth. This is the Earth Science Classroom. Thanks for watching the video. If you liked it, please subscribe, like, and share. And if you want more content and videos on Earth science, please check out my channel.